All right, everyone. So I'm gonna work through the practice exam number 3 here. So number 1, this is looking at 2 potential equilibrium outcomes for the market of Christmas trees. We assume that everything's the same in these 2 markets. The only thing different is the market structure. So example 1, let's write this down. There's a price of $50 per tree, and the quantity is 100,000 that's sold. Example 2, the price is $60 per tree, and the quantity sold is 80,000. All right. Now you're supposed to say, well, what could they potentially be? You're not sure for certain, but what you're wanting to do in this problem basically is like, okay, you want to match up, like within these market structures, there's certain things that's going to happen here. So we have perfect competition here. We have monopolistic competition here, oligopoly, and monopoly. All right. The lowest price is going to start with perfect competition. The second lowest price, monopolistic competition. Oligopoly is going to be in between monopolistic competition, and monopoly is going to have the highest price. Okay. Now, with quantities, it's the other way around. Monopoly is going to have the lowest price, lowest quantity, then oligopoly, then monopolistic competition, and then perfect competition is going to have the highest quantity. And that's because, perfect competition is the most efficient. It's going to have the largest surplus, whereas monopoly is the least efficient. Okay. All right. So we need to find the case. So we know with example 1, the price is $50, the quantity is 100. So we know it's going to be more efficient here than example 2 because the price is a little bit higher and the quantity is not as much. All right. Example 2, there's a little bit of market power, and because of that, they're reducing the production and they're getting a higher price for it to increase their profits. So let's look at some examples here. Monopolistic competition, could that be example 1? And perfect competition 2? Well, no, because it's going from monopolistic competition to perfect competition, the price is actually getting higher, not lower here. B, monopolistic competition, and example 2 could be monopoly. Well, this could be the case. Example 1's lower, so that monopolistic competition has a lower price than monopoly. We know that because of the barriers to entry and stuff like that, because of the efficiency. And it's the same thing, same way with the quantities here. The quantity on monopolistic competition is going to be greater than on monopoly. So this potentially could be one of the markets. This could potentially be the way these markets are set up here. Right. So it's going to be B. And if you look at C and D, it's the same way. You're going from oligopoly to perfect competition or oligopoly to monopolistic competition. Oligopoly is going to have a higher price. Right. So it can't be example 1. That's why it's not the case here. That's kind of how this problem works. This is kind of like seeing, okay, do you understand, how this works with the prices on these in comparison to others and the quantities and which ones are more efficient. So make sure you understand that when you're kind of doing a comparison between all these different market structures. All right. 2, perfectly competitive firms can earn a positive economic profit in the long run, but they cannot earn positive accounting profits in the long run. Well, this is false. Because in the long run, price is average total cost in the perfectly competitive market, 0 economic profits. But positive accounting, because accounting is always higher. It's at least, going to be at least 0, but probably more than that, because you're taking into account your opportunity cost. You may have a better deal, something you could do elsewhere. So that's why when these firms are deciding whether to enter the market, they're looking at, they're comparing all their different opportunities they have. Okay. and they're not going to join this market unless it's the best thing where they can get the highest amount of profit here. And so when you take into account this opportunity cost, what's going to happen, this is going to trend towards where there's zero economic profits, where the price is equal to average total cost. 3, at their respective profit maximizing price and quantity combinations, firm A's good as a price elasticity of -1, and firm B is good as a price elasticity of -4. Which of the following statements is true? Well, we want to find their learner index, firm A's learner index, and we said this is 1 over negative elasticity of demand. And so for firm A, we said it had elasticity of demand of -1. So this is essentially learner index here of 1. Firm B, learner index 1 over negative, we said they had a price elasticity of -1.4. So this is going to be like 0.71. Remember, these learner indexes are always positive. Okay, they're always going to be positive. And so B and C have indexes of a negative number here. Those would be right if it was, positive, but they're negative, so those aren't correct. A, firm B is learner index of 1.4. No, it has elasticity of demand. It doesn't, it needs to be the inverse here. But what this is saying, this is the point of these learner index, the higher it is, the more markup power the firm has. And, therefore it's able to raise its price, further up above percentage-wise compared to its marginal cost here. So this is going to be C. Okay. Firm A has more markup power. That's what it's essentially saying here. The higher this number, the more markup power they have. Okay. 4. If 2 oligopolies in Berkshire competition produce similar goods, the price will be set at marginal cost. So pay attention here, like with this. When they have to be producing identical goods. When they produce identical goods, price will equal marginal cost. If not, the price, they'll have some market power, the price will be set above it. All right. That's because, just because the other firm undercuts their price a little bit, it's not a completely perfect substitute. So, they'll lose some business to that. Some people buy this other good because it's cheaper, but they still have some brand loyalty to it because it's not an identical good, and they still, they still have some market power. They can market above, their marginal cost in this case. So that's going to be false. That would be true if they were producing identical goods. Okay. All right. So we're going to use a diagram for the next 2 questions. Jed and Jethro are the 2 local organic tomato farms in Flower Branch, Georgia. If they cooperate in lower production tomatoes each period, they can increase their profits. Here's their payoff matrix from high production and low production. Let's write this out. So Jed is the row player. He can produce a lot of tomatoes or a low amount of tomatoes. Jethro is a column player. He has the same thing, high production tomatoes or low of these organic tomatoes. Then let's write off their payoff matrix. 20, 20, 100, 10, 10, 100, 80, 80. All right, what is the Nash equilibrium? Well, let's change it as a finitely repeated game. So let's find the Nash equilibrium here. So we're going to look at the point of view of Jed, and he's thinking, well, what am I going to do based off what Jethro does? He's always got to take that into consideration here. If Jethro chooses the high production, Jed has a choice between 20 or 10 here when he does low production. Well, he's going to choose the high production. Okay. What about if he thinks that Jethro is going to do low production? What's his best move? Well, it's high production as well. It's just 100 better than 80. So Jed has the dominant strategy here. He's always going to do high production. Okay. Now let's look at it from the point of view of Jethro. All right, what if Jed chooses high production? What should Jethro do? Well, he's got a choice between high production 20, low production 10. Well, he's going to choose high production. What about if Jed chooses low production? Well, he's got a choice between 100 and 80. Well, he's going to choose high production and get 100 here. So same thing with Jethro. He has a dominant strategy of always producing a high quantity of organic tomatoes. And so we know the national equilibrium here is going to be 20-20. Right. High production from Jethro, high production from Jed, high production from Jethro. Okay, and they'll both get a 20. It'd be better off to cooperate, but there's always incentive for them to cheat here. All right. Now it's asking, what about this was a finitely repeated game? Will this make any difference? Well, no, because through backward deduction, they'll go to the last game that's played. They'll know that's the end point. They know how many games we're at. And there's no incentive for them to cheat there. And so because of that, all right, it makes it where it's a case where what's the point of cooperating in the period before that? Because if they don't cooperate, then you can't punish them the next period because that's the end period. And at that point, there's nothing to be done. People are going to act selfishly at that point. All right. And this process will just keep repeating backwards. So basically with a finite repeated game, it's no different. The results are going to be the same here. Okay. So there's going to be no change. So that's A, Jed and Jethro both choose high production. And it's a finite repeated game. There's no difference. Okay. So that's 5. What is 6 asking? Let's say they're using a tit for tat strategy for a repeated game. Let's say they're playing it need to be an infinite repeated game. They know each other's strategy. It's a tit for tat, which means if one of them deviates, they don't cooperate. Like if they're saying, okay, let's both do low production. They both get 80. And then Jethro one period's like, well, Jed's gonna deviate from this. And he's gonna choose high production. Well, what would Jethro's response be this over the next 2 periods? Well, as long as Jed goes back at this initial period, Jethro will just respond by punishing the next period by doing high production as well. But then as long as Jethro goes back to cooperating that period, well, the following period after that, he'll go back to cooperating as well. Okay. So you punish 1 period for every time you deviate, and that's the next period. And if you go back to cooperating, okay, you will the following period. So with that, it's going to be B, high production, you punish 1 period, and then low production, go back to cooperate as long as Jed goes back to cooperate. Okay. All right. And make sure you know the other kind of grim trigger. This is when once somebody deviates, that's it. You don't cooperate ever again. All right, once someone deviates, once they're cooperating, doing low production, getting higher, then one of them deviates, and that's it. It's back to not cooperating this high production from then on. Okay. Let's see here. All right, number 7. Oh man. T-shirts are produced in a perfectly competitive market. Each identical firm has a short run total cost curve of TC 4Q to the third, 20Q squared, plus 65Q, plus 200. Okay, that's their total cost. And the quantity is measured in thousands of t-shirts per week. The marginal cost is given by 12Q squared minus 40Q plus 65. Now what we want to find here? Well, we want to find the shutdown price. Well, they're going to shut down once price falls below average variable cost. Okay, that's a short run shutdown cost. They're going to ignore these fixed costs that they can't do anything about. when they're deciding whether to close the short run. Now, in the long run, when they can change all these prices, it's a different story. Well, first thing we do, we need to find the average variable cost. What is that? Where you're going to take the parts of the total cost that are actually variable, that change with the quantity, and you divide it by Q. So you have 4Q squared instead of 4Q to the third, minus 20Q instead of Q squared, and plus 65. We ignore the fixed cost of 200 because this is the short run. We're only concerned about what we can actually change. And what we'll do is we'll set average variable cost equal to marginal cost. So 4Q squared minus 20Q plus 65 equals the marginal cost of 12Q squared minus 40Q plus 65. Well, the first thing you do is mark out these 65s. They cancel out. Add 40Q to both sides. 40Q minus 20Q will be 20Q. And subtract 4Q squared from both sides. So 12Q squared minus 4Q squared is 8Q squared. What can we do here? Well, we can divide Q from both sides. That'll make that be 8Q. It'll make that be 20. And so when we divide both sides by 8, our quantity is 2.5. That's what we solve for here. This will be the quantity that gets where the price is equal to the average variable cost here. All right. So what we need to do is, okay, let's find this. What is this price here when this quantity is produced? Well, we know the price is going to be equal to the marginal cost. And so we'll use our formula here, 12Q squared, 2.5 squared, minus 40Q, which will be 2.5, plus 65. All right, so what are we going to get here? We're going to should get a price of $40. Okay. This is the short run shutdown price. If it drops below this, you're going to shut down because it makes no sense to stay open any longer because you're ignoring your fixed costs. You're losing money on that, but you can't do anything about it. But even by staying open, the additional variable cost that you're facing is more than the revenue you bring in, so it doesn't make any sense. All right. Now let's do part B of this. What is the firm's profit? The market price is $45 per shirt. Okay. All right. So we know profit is equal to price minus average total cost times the quantity. The shirt is $45. The quantity we're going to use here is 45. Wait, did I do this right? Thank you. I don't think I did this right. All right, let me stop here and think about this. We'll start back afterwards. All right. Let's see here.